Hey everyone, my name is Andrew Coyle, and I'm here with my team Jared Schneider, Larry Lee, and Vincent Bello, and we decided to build a wireless COVID-19 contact tracing system. So let's go ahead and dive into a brief overview of the project. So wireless COVID-19 contact tracing is a method of determining individuals that may have come in contact with other individuals who have tested positive for COVID-19. We obtain this data by analyzing devices on the network that are connected to a particular wireless access point. Um, when we discover that a certain person has tested positive for COVID-19, we can then look at all the wireless access points that that person has connected to, and we can see all of the other devices that were connected to that particular wireless access point at the same time. And from there, we can notify all of those other individuals that they have possibly come into contact with someone that was diagnosed with COVID-19. Um, by alerting these individuals, this could potentially result in a rapid testing and quarantine, which would ultimately reduce the spread of COVID-19. Now let's go ahead and dive into how the system actually works. All of the functionality of the system is contained in a single Python program that's going to be operated by some user. First, the user is going to enter an IP address of a target wireless access point. This wireless access point is going to be the point where the user will conduct the contact tracing. From here, the program will take that IP address and run nmap, which will then ping all devices on the network. And here we're looking for a few things. We're seeing if a device has just joined the network. We're seeing if a device left the network, and we're seeing if there any device that is remaining on the network. This will be repeated for 4 more times, although this number is arbitrary. You can do it as many times or as few times as you'd like. And here we sleep between 30 seconds in between. You could technically run this process indefinitely and just continuously scan the network. During the recording process, the Python script will keep track of all start and end times for all devices that have connected. Once the recording process is done, it'll supply the user with a list of MAC addresses that have connected over a certain interval. After that, the user can enter a MAC address of someone who has tested positive for COVID-19, and then the program will supply a list of MAC addresses that were connected to that same wireless access point at the same time, and then we can go ahead and inform those that they may potentially have come in contact with someone who has tested positive for COVID-19. Here we have some different function examples that were used in the Python script. So you can kind of see here we have a function that's designed for reading in the MAC addresses. We have a function here that's designed to figure out the end times, and we have a function here that actually prints out all of the possible COVID devices. Here are some improvements that we considered as we built the system. So first, we could have allowed for some sort of multi-threading, which would allow for our program to continuously check for devices. If we wanted to scale this system up, we would definitely need some sort of database. Currently, as we were running it, we had enough memory and processing power for everything, but if we were to scale it up, we would definitely need a database to keep track of everything. We also thought about a notification system. If someone comes in contact, or if a group of people come in contact with someone who potentially has COVID-19, we would obviously need an easy way to inform these individuals. And then finally, we thought of security issues such as IP spoofing and MAC spoofing, and we would need some way to prevent that as well. As stated in the previous slide, if we were to upscale this, we would definitely need to utilize some sort of database. So here we've included a database diagram. If we were to utilize a database, we would obviously need to be able to code for that. We would probably use the Python library SQLite 3, which would allow us to interact and use database commands. And here's an example of a function that finds users who are at risk from a positive user. So of course, as we were building our system, we ran into issues. Here are a few issues that are still present in the system itself. So first of all, if you're running the system from VirtualBox, you must first change the network setting to bridge adapter, which essentially allows the virtual machine to use the local host IP address. Another issue that we ran into is occasionally the program throws an exception for some infinite loop. We have no idea why it's doing that. It seems to be a very uncommon thing, and if you want to quit, just use Control-Z and try to run it again. And then finally, the Python file uses sudo to run nmap, because if you do not use sudo, it will not show enough information, particularly it will not show the MAC addresses. So the user will need to enter their password every once in a while, but the user can easily configure sudo to not ask for a password if they so choose. That concludes our presentation. Thanks everyone for listening in. If you have any questions, feel free to reach out to me or to any of my group members. Thank you.